Hi everyone, welcome back to TechnoCoders. In today's session, we'll be understanding about links in Unix. So we will learn about soft links, symbolic links, and hard links. So basically, what links mean in Unix? Links provide a mechanism to create a shortcut or different name for existing file or directory. It may be helpful to have two different names that refer the same file. So what that mean? So this is similar to like in Windows we have shortcut, right? Suppose you have some files in C drive and there are multiple folders inside it, and you don't want to go in each and every folder. Instead of that, you directly create a shortcut in desktop. When you click on the shortcut, it will directly take you to the path. So this is how the links work in Unix. So this is the command ln make links between the file, and how to invoke it. Ln option for like creating soft link or hard link, original file name, the file for what you want to create a link, and this is a link name. This can be anything, any name you can give. So this will create link for this particular file. So now going to the types of links. So we basically have two types of links: soft links, or we call soft links as symbolic link as well, and we have hard links. So in the left side, you can see how the soft links work. So let's say that this is a file. Okay, I'm creating soft link on the file. So when I create a soft link in the file, it will attach to this particular file. And when I'll invoke or open the soft link, it will actually opening this particular file, which is residing into file system, and inode number is given. So what is this inode number is each file and directory in Unix have a inode number. This is how data is identified in Unix. Okay? So soft link, in this example, you can say soft link to connect to the data, it is go via the file. Okay, and if you see in the right side, this is a hard link. So in hard link, this link is directly accessing the data. There is no relation directly to the file. So what that means is, if in the soft link, if I delete this particular file, right? If I delete this file, this link will be broken. But in hard link, even though I've deleted this file, this hard link still will work, because this hard link is directly created on the data. Another difference is when you create a soft link side, it will create a different inode number, because soft link is nothing but a type of a file, a special type of file. So it will give the different inode number. But if you create hard link, multiple hard links, they will always having the same inode number only, because it is directly accessing the data. That way accessing is very faster. Second thing is soft link, you can't in soft link you can create soft link on the directory also. Like this example is file, you can create soft link for directory also, but hard link can't be created on directory. Another thing is, in soft link you can create for different file system. If you have two different file system you are accessing, you can create soft link there, but hard link can be created only on the single file system, same file system. Let's see one by one with examples. So here, soft link or symbolic link. A symbolic link is a special type of file that refers or point to another file or directory. See in this diagram, this is a special type of file which point to this particular file or directory, not directly to the data. So soft link is pointing to the file. You can access original file data using any of the created symbolic link. So example, if I'm creating soft link or symbolic link, if I open this link, it will actually opening this file, this data file it is opening, right? Removing the symbolic link does not affect the original file. So it means if I remove this symbolic link, this file is still intact, because this file is currently pointing to the data. But if you delete the original file, then all symbolic link file will be broken and we can't access file anymore. So what that means is, if I delete this file, then this link will be broken, right? So if I delete this soft link file, no impact on the file. But if I delete the file, this link will be broken. And there is a command to find the broken links. We will see next in the example. So this is how we'll be invoking and creating the soft link. Ln-s command, -s for the soft link. This path can be either a directory or a file. We will see both how we can create it. And this is how I'll be running it. Ln-s, I will give my file name and I will give my link name. And by running this command, link will be created. Now let's try to run this command. So for this demo, I created one test file, test-softlink.txt. Let me try to open this file. So you can see that in this file I have a line written that this is a test file for the soft link. Now I'm trying to create a soft link. So ln-s, give the file name for what you want to create. See, if your file is in a different directory, that also you can give the full path starting from the root. Okay, but because my file is here, I will show you both the side. First I'm creating in the same directory. So test softlink.txt and give the name whatever you want. I'm saying new soft link. Okay, I'm just creating ln. So I'm just creating ln -s to create a soft link. This is my file for what I'm creating a soft link. Just run this command. Now just run this ls -lrt command just to list the file, and I'm using I option here to see the inode number also. I will show you why this inode. So if you use -l is for long list, r is for reverse based upon timestamp. So my latest file will be shown in the last, and then I'm using I to display the inode number in the first place. So you can see this is my inode number. Now if you see carefully here, right, my file is testsoftlink.txt. My inode number is 29729, right? But when I created a soft link, my inode number changes. It's a new inode number. This is what I was explaining you here in this line number. So when this inode number is for the data, but when I'm creating different soft link, it is creating different inode numbers. So inode number are differing. Okay. Now let's try to open this file. So cat, instead of opening the file, I am opening the soft link. See here, same content it is showing, because this new soft link is actually pointing to testsoftlink.txt file. And how to identify this kind of file is, in the first place, if it is a normal file, it will look like hyphen here. It's a regular file. If it is a folder directory, it is a D. If it is a link, then it will be L. So this is how you will be seeing it. Now let's try to create this soft link into another directory, because my file is here, right? So I am going to another directory now. So here I don't have this file actually, right? Testsoftlink.txt. Now I want to create a soft link which will point to file into another directory. So again, same command, ln -s, give the file name, because my file is not here, it's in another folder. So I need to give the full path. So my file is actually here, right? In home technocoders folder. So root home, my user technocoders. Here I have my file here. This is my file testsoftlink.txt. So I am creating link for this file here, and I am giving new soft link 1. I am giving different name, new soft link 1. You can give the same name also, because you are in different folder. No, it doesn't matter. But just I am showing you it's another link here. So let's see if link got created or not. Now you can see here new soft link 1 got created. Now this is pointing to home technocoders test softlink.txt. Now let's try to open the file again. New soft link 1. See here, it is showing the content of this file. So this is how you can create a link. Again, if you notice here, if I run ls -lrti command, now I got another inode number, right? It's a different inode number. So every time I'm creating different soft links to the file, it is creating different inode number. Now this is how you creating soft link for the direct files. Now let's see how you can create soft link for the directory. So now if I do pwd present working directory, this is my directory. Now let's say that instead of every time I'm doing cd home technocoder test cell, I want to create a link to this directory, and anytime I accessing that directory, it will show the content inside this directory whatever available. So use the same command ln -s. Now give the, instead of file, give the directory you want to create link for. So here is my directory, and I am calling this directory, and I'm say my dir. This is my link name. This is my directory. Okay. So let's try to run this command. See here. Now my directory. Okay. This is my link directory. This is actually pointing to home technocoders test cell. So example, if I do cd my dir, right? See here, this directory, all the content whatever is there inside my cell, it will be showing here. Now once you understand how we can create soft link, now try to see how you can unlink or remove that links actually. So I'm going back to my directory again. So here I have new soft link which is pointing to this particular file. I want to remove this. So there are two options actually. Either you can use rm command, rm, so it will remove this link, rm new soft link, it will remove it, or you can use unlink also, unlink. So unlink the name of that link, soft link. Now let's see what happens. So that my link my link got removed. Okay, so new soft link 1 got removed. So this is the way you can unlink, you can unlink the directory also. Unlink my dir. See, directory also got unlinked. This is the way you can link or remove the soft link in the system. Now let's see that what happens if I remove the original file and link is still existing. To show that, first let me try to create a link again. So here I'm again creating a link. So my link got created, and now this link actually is pointing to this particular file. Let me try to remove this file first. So I'm going one directly back and I'm removing the file. So this file got removed only. Now again, if as soon as this file got removed, you can see one soft link which is already existing in current folder, it's showing in red, and I have another soft link in my test shell folder. Let's see what happens there. This is also showing on red. If I try to open this link, right, see no such file or directory. So it means this file got deleted, right? That link is no longer exist. And now suppose you want to find the broken links, like if you can see here, it's in red, right? You want to find this kind of broken link, then you can use find dot is for current directory and use x type L as for the links. So this will return you the file for what the links got broken like this, and then you can use the same command with the delete option, or you can remove that link also separately. But you have hundreds of links which got broken, then you can use just simple command find current directory dot x hyphen x type L is for list and then delete. It will delete all the broken links, and after running this command you can see this link got removed which is broken. So that way also you can find the broken links and remove those. Now let's move to the hard links. So now in hard link, so each hard linked file is assigned the same inode value to the original. Okay, so therefore they are referenced the same physical file location. So what that means is, if I go back, this inode number, right? This inode number, if you create multiple hard links, so all the links you are creating will get the same inode number. So it means they will directly access to the data. But in soft link, if you notice, right, every time I'm creating a soft link, it was creating a different inode number. But in hard links, all the inode number, whatever you create, will be having the same number value for the original file. So link have actual file contents because they are directly accessing the data, right? So they have an actual file content. If original file is removed, then the link will still show the content of the file that I explained you before. If you remove the file, there is no impact on the hard link. But if you remove file in the soft link, that link will be broken. Hard link is a mirror copy of the original file. Deleting the original file will not impact anything because the hard link file will act as a mirror copy of the original file. By looking to this statement, you will be wondering then same thing we can do from the copy also, copying the file. See the difference here. If you are copy the file, right, copy the file will create additional data storage because it's just copy. Second thing is, if you modify into one file, the second file is not impacted. But in hard links, what happens if you modify the original file, right, original data, whatever hard links it is pointing to, the changes will be reflecting. So don't confuse. You can't do the same thing with the copy command. Copy will increase the data space, as well as if you modify one copied file, it will not impact the other file. Okay, so hard links are also shortcut to file, but hard links cannot be created in a folder or file available on the different file system. I already explained this before. A hard link is basically a second file name for the same file. So it's just a second file name. So this type of requirement very much often used when you are doing the data backups and different using the same file name, you can give the different file name so that once you modify the original file, all the file pointing to do will be showing the reflected values. So it make efficient use of the disk space by avoiding the necessary creation of block record. The speed of hard link is faster. The reason is because you are directly accessing the data block, right? The inode number, so it's faster. You cannot hard link directly as compared to sorting that I explained you before. This is the command. Only difference is here you will not be using -s command. -s is for soft link. When you want to create a hard link, just use ln, give the file name and give the hard link name what you want to create. Let's try to create one hard link and see the difference compared to soft link, and we will see the advantage of that as well. So in my current directory, I have one file test hardlink.txt. I'm just opening the content of this file. At test hard link.txt. Okay, so the content of this file, this is a test file to test hard links. Now let's try to create hard link here. I will create multiple hard links. One is in current directory, one is another directory. So first I'm creating here ln. Here I'm not giving any option here because I'm creating hard link, and give the file name test hard link dot txt and give the name of the link new hard link. Just enter it. Now see the difference here. So hard link got created, right? See the difference. This is my file, right? And this is my hard link. And if I run the command, right, to give the inode number, so you can see here I have same inode number for these two. This is very important. So what that means is this file is also pointing to this inode number in the data. This new hard link which I have created is also pointing to the same data. So if I try to open this hard link which I have created, right, new hard link, see it is showing the same content here. Now what happens if I try to modify the file? So let's try to modify the file. Then .txt, I'm opening the file, I'm modifying, typing modification done, saving it. So I modified this hard link.txt, but now I'm opening the another file, the hard link file I have created. See here, it is showing the modification here also. So why it is so? Because both are pointing to the same data block here. Even though if I go to different directory, right, let's try to create into another directory. Here I want to create hard link again, so I'm giving ln, then file name. So my file is actually in another folder, so I need to give the whole path. So home technocoders, give the file name and create a hard link here in the current directory and give name as new hard link 1. Let's see. See here my hard link got created. Now let's try to check the inode number here again. See here also 29735, even though I'm in different folder here, right? I am in test cell and this 29735, and here also in my previous directory it is showing the same inode number 29735. So this is the way you can create different hard links, and when accessing data is very faster, and you can think like that, when you want to have same file with different name, you can always use that. If you want to have your access faster, you can always use that. But only drawback of this is you can't create hard links on the directory. Also you can't create hard link on the different file systems. I hope this is clear. And again, if you want to unlink or delete rm command, then use the same command. Either use rm to remove or use unlink. Unlink, give the name new hard link 1. So this link got removed. But even though I removed my link, right, the original file or the different link will still existing. See here, new hard link, it is still there. But even if I remove the original file also, like I'm removing the actual file, hard link.txt, I'm removing the original file, and even after that my hard link still exists, and I try to open the file, I can still see the data, right? So this is the way hard links works in Unix. I hope you like this session. So we understood how the soft link or symbolic link or hard link works in Unix. And thanks again for watching this video.